So, to better understand how to make graphs do different things for our Desmos project next week, which is going to basically take all of these parent functions we're going to talk about in this lesson, in this activity today and tomorrow, and create a picture using all or parts of some of these functions. So, in order to understand how to move functions and change what the graphs look like and things like that, we're going to do this transformations packet. And we're going to be looking at the parent functions for quadratics, exponentials, absolute value, cubic, vertical lines, horizontal lines, all the things. We'll be exploring how they move, left, right, up, down, reflect, squish, narrower, wider, all the different things. So I am going to go through with you today just the quadratic function to show you how all of the graphs work, how the equation works, that kind of a thing. And then you're going to be responsible for for the rest of the packet. So we're going to start with a quadratic. A quadratic basically means you have got one x or an x squared or a y squared, but nothing else squared. Just one of the variables is going to be squared. And the graph of a quadratic function basically looks like a U. Oops, daisies. It looks like a U, something like that. Or it could also look like this. Next week we'll also talk about how we can turn it to make it look like this or like this. But for today we're just going to focus on these two types of parabolas right here. So when we talk about a parent function, the parent function is basically what the equation is without anything done to the graph. Anything done to it, nothing added, nothing subtracted. And the parent function for a quadratic is just y equals x squared. So let's look at what the graph of that actually is. And if we are going to do y equals x squared, here I have here's my parent function that I have listed right up here. And in order to kind of understand where our values come from, you're not going to have to do a t-chart or anything like that for all of them. But if we did a quick little t-chart here, x, y, if x is 0, 0 squared is 0, so we'd have an ordered pair there. If x was 1, 1 squared is 1. If x was 2, 2 squared is 4. If x was 3, 3 squared is 9. And we would just take these and plot them on our graph. We'd have our ordered pairs. We'd have 0, 0. I'm going to make it in red so it's easier to see. 0, 0. We'd have them, and then basically we'd have the exact same thing reflected on the other side. So 1, 1, then we'd also have negative 1, 1. We'd have 2, 4. We'd also have negative 2, 4. And then if we had 3, we'd have 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. We can't actually fit 3 on there. So this graph, and it's a parabola, it's like a U. It is going to be a soft curve at the bottom. It is not a point, it is a soft curve, okay? So basically what I want you to do right now is I want you to take this parent function that we just graphed, and I want you to basically copy and paste it on each of these graphs in this quadratic page, because we want to make sure we have, the parent function is what we compare everything else to. So we're going to have that function on every single one of our graphs, and then we're going to do all of the transformations it talks about. Up 1 unit, down 2 units, all of that kind of stuff. So I want you to pause the video, and I want you to actually put this parent graph on all of your graphs that we have here so far. Okay, so as you can see, the first thing that I did is I took and I just copied that parent function with those points on it that we found to each of these different graphs. And then what we're going to figure out is how we can do different things. We can move the graph left, right, up, down, reflect it, make it skinnier, make it flatter, make it wider, all those different things. And in order to do that, we need to understand the standard form of a quadratic, which is listed right over here. Okay, and each piece there has a different piece of information that it tells us, okay? This number out in front right here, so daisies, I want that to be a pen. That number A out in front, whatever is out in front of the parentheses, does a couple of things. It either, it stretches, well, let's not call it stretches. It can make the graph taller and skinnier. Okay, it can make the graph shorter and wider. And it can also reflect the graph from a smiley face to a frowny face. Okay, so that lots of things that number out in front can tell us. This number right here, this h value that's inside of the parentheses with the x, inside of the parentheses, inside the squared, is going to move the graph left and right. And then this k value right here is going to move the graph up and down. Okay, and you are going to be able to use your Desmos graphing calculator. Okay, so you're going to have, I would recommend probably, if possible, having it like dual screen or something if possible. So you're going to be able to use the Desmos graphing, and you're going to be able to use the Desmos graphing for everything that we do this week and next week. So make sure you're becoming familiar with how to enter things into that graphing calculator. So go ahead and open up your graphing calculator if you want to. And then what we're going to do first is we're going to figure out how we translate this red graph up 1 unit. Okay, what that equation is going to look like, first of all, is going to be here in this box. We're going to write the equation here. And remember, we said we're going up 1 unit. That number on the outside of the parentheses moves things up and down. Well, if we are going to go up 1 unit, we're going to go up x squared, and we're going to have a plus 1 because we're going up 1. Okay, and all that that's going to do is it's going to take this red graph and every one of those little red dots that we have on there, you're just going to move it up 1. So we're going to go from, move that vertex here, up 1, up 1, up 1, up 1, up 1. And we're going to have basically the exact, up 1. Basically, we're going to have the exact same graph, just moved up. Oops, I didn't trace that very good, but up 1 unit. Okay, so that plus 1 on the outside said we're moving it up 1. Similarly, right, if we were going to move it down 2, we would have y equals x squared. And instead of adding, we're going to subtract. We're going to go down 2. So we're going to take all of these, each individual spot that we did, and we're going to go down 2. 1, 2, we're going to go there. 1, 2, we're going to go there. 1, 2, 1, 2. And basically, we're just going to sketch it right over the top of it. And again, I might not have done a perfect job with that, but it takes that red and it just scooches it down 2 units. Okay, so now we want to reflect over the x-axis. So we're going to have y equals, it's always where we're going to start. Remember, we said that that a value out in the front is how we're going to reflect. Well, if we want something to go from going upwards to downwards, we're going to put a negative out in front of it. So we're going to say negative x squared. And all that's going to do is it's going to take each of these ordered pairs. Well, this 0, 0 is not going to move, but it's going to reflect each of those over the x axis. So currently this one is up above 1, below 1, above 1, below 1, above 4, 1, 2, 3, 4, below 4, above 4, below 1, 2, 3, 4. And we're going to do a little sketch of our graph like so. Again, we have ordered pairs on there and it's just a sketch basically. Okay, so now we're just going to keep doing the exact same thing. Now we're going to go to the right 3 units. Well, if we come back up here to our formula up here, our standard form, that number inside of the parentheses moves things left and right. Okay, so if we are only moving to the right 3 units, we're going to have y equals, okay, we're going to have something in parentheses squared. The 3 is going to be inside of the parentheses. We're going right 3. And if we are going right 3, that means that we are going to have a minus sign in here. Okay, so if we're going to go in the positive direction, it seems a little backwards, but if we're going in the right, in the positive direction, that sign inside of the parentheses is actually going to be negative. So it'd be x minus 3. So we're going to take each of these points that we have, and we're going to go to the right 3 units. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. And again, it's just the same exact graph. We've just moved it to the right. And similarly, if we want to go to the left, okay, we're going to have y equals. We're going to have something in there with my x, and it's going to be squared. If we're moving to the left 4 units, we're actually going to have a plus sign. It seems like this would be the negative direction, which means we're going to have the opposite sign in our parentheses. So we're going to have an x plus. We're just going to put the 4 in there. And all we're going to do is we're going to move each of these points 4 units to the left. 1, 2, 3, wait, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, and ba-doop, ba-doop, there we go. Just like so. Okay, so left and right, remember if you're going in the positive direction, this sign right here is going to be negative. If you're going in the negative direction, this sign is going to be positive. So that's one of the confusing things to remember. If you want to make the graph taller or skinnier, that means your A value is going to be greater than or equal to 1. Okay, or actually it's just going to be greater than 1. Take that out of there. It's going to be greater than 1, and the bigger that number is, the skinnier the graph is going to be. So if we do a factor of 3, it's going to get skinnier, but if we did a factor of like 100, it'd be super, super skinny. So we're going to have y equals, again, and it's a factor of 3. That's the number that's going to go out in front of our x squared. So when we do these, we're just going to basically take each of these values and multiply them by 3, which the 0 doesn't change. This 1 times 3 is 3, so we're going to be at 1, 2, 3. It's going to be right on the other side. And this is at 4, and if we multiply that times 3, we would actually be up off the graph somewhere. But so we can't actually graph it, but it's going to be a skinnier version like that. It's just going to be skinnier than the original parent function. If we're going to squish the graph so it's wider and flatter, so it's going to be more like that. The smaller the fraction, a half is going to make it a little bit wider and flatter. If it was like 1/100th, it'd be super flat. So we're going to do the exact same thing. We're going to put that 1/2 out in front, and we're going to do x squared. So again, here we are. We're going to be at 0, 0. That doesn't change. 1, at 1 instead, it's going to be at 1/2, because we're going to be at 1/2. And at here, when we're at 4, half of that is 2. So we're going to be here and here. And basically what it's going to do is it's going to make it wider and flatter. Okay, so that's how the equation works. Things that are inside of the parentheses move it left and right. Outside of the parentheses are going to make it go up and down. And then that number out in front is going to either reflect it, going to make it skinnier, or it's going to make it wider. Okay, so let's look at some more examples here. All right, so we're going to do our parent function, right? We're going to take our parent function and move it left 3 and down 1. What would my equation look like first? Well, before we even do our equation, let's go ahead and put our parent function on there, right? So 0, 0, our 1s, 2, 4. Okay, that's just every time it just helps to see where we're going and what we're doing. And our points that we're going to actually be moving. Okay, so if I am moving to the left 3 and down 1, I'm going to get y equals, so I'm going to go in black here, y equals, in our parentheses, if we are moving left 3, left is negative, which means inside of our parentheses is going to be x plus 3. This is always squared. The x value is always going to be squared. Down 1 means we go minus 1. And so what that means is our red parent function here is going to go left 3 and down 1. 1, 2, 3, down 1. Oops, I didn't want those dots on there. 1, 2, 3, and down 1 will go there. 1, 2, 3, and down 1, down 1, 1, 2, 3, down 1, 1, 2, 3, and down 1. And what we have is, again, just what we've been doing, the exact same thing right there. Okay? So then we're going to come down here to another practice one. Again, we have our red parent function, which is here and here, and negative 2, 4, and positive 2, 4. Here's our parent function that we're just going to compare to. What if I wanted to make my graph taller and skinnier by a factor of 3? So that's going to be, that A value is going to be 3 out in front. And we want to move it to the right 2. So grouped with my x, we're going to move it to the right. Remember, if we move it to the right, thinking that's the positive direction, in our parentheses is going to be a minus 2. And then up 4 means we're going positive 4. Okay, so basically we're going to take each of those points. We're going to go to the right 2, up 4, and then we are also going to multiply them by 3, which is going to be a little bit crazy. Okay, so we're going to go to the right, the right 2 and up 4. So let's do those guys first. To the right 2 and 1, 2, 3, 4. Look at that, my vertex is going to be on the same spot as the other one. And then we're going to go 1, 2, 1, 2, 3, 4. Oops, the daisies. Let me fix that. Okay. So this, my vertex, what did I say? I'm going to go to the right 2 and up 4. 1, 2, 1, 2, 3, 4. There's my vertex. Okay. And then from there, I'm basically going to, might have to do a little bit of calculating, but the idea is we are going to make it skinnier by having this 3 out in front. I'm not going to do an exact set here, but we are definitely going to be skinnier than we were before. Okay. And you could always use Desmos graphing to help you out with the ordered pairs on there. And then now we're just going to go the other way. Given the following equations, what are the transformations? Transformations would be left and right, up and down, reflected, stretched, that kind of a thing. So if we have 3 things going on here, right? We've got a 2, a 6, and a 9, okay? That 2 out in front, remember the 2 out in front, that bigger that number is, the skinnier it's going to make it. So this is going to make it taller and skinnier. The minus 6 in the parentheses, remember minus means we're going to the right 6. And then the plus 9 means we are going up 9. Okay, and then on the next one, we have a negative out in front. That negative says reflect. The plus 2 means we are going to the left 2, and the minus 8 means we are going down 8. Okay, oops, daisies, I got a little too far. So that's, I went through the entire thing with you for the quadratics or the parabolas. All I'm going to do in the rest of the video is I'm just going to show you the parent function and the equation, the standard form, and then you're going to do the exact same thing that we did on this last parabola one. You're going to have numbers grouped with the x, you're going to have numbers grouped on the outside, you're going to have things that are going to make it reflect, all the same thing, just it's going to be a different shape of a graph, but the whole process is going to be the exact same every time. So let's look at absolute value, okay? The absolute value function is actually, it looks like a V, kind of looks like a parabola, except it actually does have a distinct point or a mountaintop or a valley, if you will. The parent function is y equals the absolute value of x, okay? And basically the parent function, I'm going to do it in red, is going to be at 0, 0, and then we're going to go, basically going out each side, it has a slope of 1 over 1. So we're going to go up 1 over 1, up 1 over 1, up 1 over 1, back 1, up 1, back 1, up 1, back 1, up 1, and so on. And we're going to have our parent function is going to look like that, okay? So what I want, and then, so what I want you to do, first things first, is I want you to copy that parent function onto each of your graphs so you have something that you're comparing to. And then if you look, again, this A out in front does the exact same thing that it did with the parabola. The H does the exact same thing. Notice it is grouped inside of these grouping symbols, and the K does the same thing, up and down. Those are all going to do the same thing, and basically all you're going to do is you're going to go through and you're going to take that red parent function and you're going to write the equation. Okay, so you're going to write the equation each time, and then you're going to graph it below in each in each coordinate plane. Okay, and then you're going to do the same thing. Here's what we did together with the parabola. How would you write the equation? Left 2 and up 1, reflected, moved right, down 1, and then describing the transformations. This is just the same thing, except it's an absolute value instead of a parabola. Okay, and then the next one is the cubic function. Okay, the cubic function is y equals x cubed, hence the name. And the parent function for a cubic function is going to look like this. It's going to be at 0, 0. Oops, let me at 0, 0. And then if x is 1, 1 cubed is 1. Negative 1 cubed is negative 1. If x is 2, 2 cubed is 8. 1, 2, 3, 4, 5, 6, 7, 8. And then at negative 8. And what a graph of a cubic is going to do, okay, is it's going to come down. It's going to curve right there, and it's going to keep going down like that. Okay, so again, you're going to copy and paste that parent function on all of your graphs. You've got, oh, look at this, an A, that's going to do the same thing. It's going to make it taller, skinnier, wider, flatter, reflect it. The H inside of the parentheses, same thing. It's going to move it left and right. The K is going to do the same thing. It's going to move it up and down, the exact same thing that we've been doing with everything else so far, okay? And then you're going to write the equation, sketch the graph, write the equation, sketch the graph, and then on the bottom you don't have to sketch the graph, you just have to describe the transformations. Excuse me. Then you have the square root function, okay? A square root function, okay? The parent function is going to look like this, where you start here at 0, 0. If x is 1, the square root of 1 is also 1. We're going to go over to 4 because that's the next perfect square. 1, 2, 3, 4. The square root of 4 is 2. And it's going to be, it starts here and it goes as a nice curve. It's not a line, it's going to be a curve. So you're going to go ahead, copy that parent function. And again, you've got the A value that's going to reflect it, or make it taller, skinnier, stretch it, that kind of a thing. H is moving it left and right. K is moving it up and down. And, well, guess what? The next thing is you're going to write the equation, sketch the graph. Write the equation, sketch the graph, and then on the bottom, describe the transformations that are happening. I know, it's a lot, but we also have exponential functions. Okay, you're going to go back and finish all of these after I just take you through the basic parent function of each of them. The exponential function has a base, and then the variable is in the exponent, okay? And the base can be different, and the value you give to the base is going to change what the graph looks like also. So I changed the bases and stuff in here just a little bit, so this one might be a little bit tougher. But the parent function with a base of 2. I just did a base of 2 on this one. It could be, the base could be any number that you want, and again, that's going to make the graph look a little bit different. Okay, so when we are looking at an exponential function, if we think of things growing exponentially, that means they are going to grow very fast. So I went ahead and made a little T-chart over here where if, oops, I should have put if x is 0, anything to the 0 power is 1. So we're going to start out with 0, 1 is going to be one of our ordered pairs. 2, 1, 2, 3, 4, 3, 8, 3, where am I at? 8, I think that's up here. And basically, if you're going to look at the graph, it's going to hug the x-axis, and then it's going to grow exponentially. That's supposed to be a straight line. Hang on, let me do a better job. It's going to hug here, and then it's going to go shoot. It's going to start shooting up very quickly, okay? And basically that's what the graph is going to look like. Please use your Desmos graphing calculator to help you with these. This is not something, you don't have to do T-charts, okay? But just make sure when I say it's a base of 3, okay, that means you're going to have y equals 3 to the x, but if it's going up 3 units, that plus 3 is going to be out here, as opposed to translating left and right down here. A base of 4 would be y equals 4. Translating to the right means you'd have the x minus 1 would be up in the parentheses like that, okay? So that's how you're going to write those. And when you put them into Desmos, if you want to graph them, make sure you use the parentheses when you do that. Otherwise, it's not going to read what you're wanting it to do correctly. And these ones where you're squishing the graph by a factor of 3 and a base of 2, that means you're going to have y equals, your base is 2, but you have a factor, excuse me, let me do this, but you have a factor of 3. So here's my factor of 3. So a factor of 3 and a base of 2 means you're going to have a factor of 3. Your base is 2 to the x, okay? So make sure that your factor is in parentheses or multiplied out in front somehow so that it distinguishes between the 3, your factor, and your 2, which is your base. Okay, similarly, like when you're doing this, you'd have a factor of a 4th in parentheses, a base of 5, and your exponent is up, or excuse me, your variable is up in the exponent. Okay, so you're going to work your way through those, same thing, and then you're going to write the equations, sketch the graph, and again, you can use your Desmos graphing calculator to help you, and then you're going to describe the transformations left, right, up, down, things like that. And then the last thing, okay, is a quick review of vertical and horizontal lines, remembering that a vertical line will only have the x variable. So if you have just the x equals 3, that means I'm going to go to my x axis. I'm going to go to 3, 1, 2, 3, and I'm going to have a vertical line through that. Okay, so go ahead and finish these next 2 as well. It's going to follow the same idea. And then a horizontal line only has the y variable, y equals 6, y equals -4. So we are going to go to the y axis. We're going to find 6, 1, 2, 3, 4, 5, 6, and we are going to draw our horizontal line. Okay, so you have the rest of the class period today and tomorrow to get this whole packet finished. So if you need to go back and rewatch any of the videos parts to remember how to write the equations or anything like that, you can do that. You can ask me if you need assistance with anything. Otherwise, good luck, and the entire packet needs to be submitted.